Hi, in this session we're going to be looking at the merge perspective in Structure 101 for C and C++, and how the merge perspective allows you to define the pattern-based rules that tell Structure 101 what files to merge to what other files. So I guess the first step, we could switch to the merge perspective up here, and I could load a project, and I'm going to load this project here. And just a little tip for whenever you're working with things like this, I'm going to stop that load process. It's quite a long-winded thing, and go in and change the properties. The main one I'm going to do here is I'm going to tell it to do includes only. And includes only has the advantage that it's the fastest way of loading a project in Structure 101. And in various scenarios, really, including merge rules, also sometimes, especially transformations, and various other pattern-based operations, sometimes even architecture diagrams, it can make a lot of sense to work in includes-only mode. That's where you're more interested in manipulating the model and experimenting, rather than actually in the end effect. So let's switch that to includes-only. Now that'll load up quite quickly. Now the merge perspective starts off completely empty. I haven't defined any merge rules yet. As a result, there aren't any merged files, and there aren't any cases where I've kind of indicated I might want to merge a file, but it couldn't find a suitable merge candidate. So I have 0 unmerged files, I have no candidates. And so I guess the first step is to define a rule, and I'm gonna define a couple of bad rules to begin with, just to try and illustrate exactly what's happening, and then we'll take it from there. So this is a bit, it's kind of fiddly typing. I guess the theory, by the way, on merge rules is that you have a fair amount of setup effort the first time you do this. And that will depend to a very large extent how the code base is structured and whether you have, to what extent you have cleanly defined modules and naming schemes, and to what extent you don't. But certainly the idea is that as you define these rules, you define them in such a way that they're as repeatable as possible. You save the rules as part of the project. And so the next time you're looking at the data for your code base, which has moved on in the meantime, but because you've defined the rules in a general way, those rules will all still apply. You might have new exceptions from time to time that you'd have to deal with, and you might not. Okay, let's go in and define a bad rule. And the general case, I think, is that we probably want to merge headers to bodies. That's what I'm going to be assuming throughout this. I have a couple of bits of knowledge already that the header files tend to end in .h and the body files with .cpp. So I'm going to say wherever you find a header file, try and merge it to a body file. And I do that, and it tells me that there are 0 merged files after I've applied this rule. And there are 6,722 cases where it thought, it looks as though you want to merge something, but I can't find a suitable merge target. So I should probably just clarify that. This area of the screen up here is where I define my rules. The merged files area is where it shows me the result of those rules, where files are successfully merged. This area is for exception reporting. It says, this lists all the files that I've indicated I might want to merge, but where it couldn't find a successful merge target. We'll come back to the merge candidates later. And that's really for dealing with problem cases, tracking them down. To understand why I've got no merged files, but lots of unmerged files, you really have to have a slightly closer look at the rule I defined. What it said is, for any header file in the code base, try and merge it to any body file in the code base. Now, because this code base contains more than one body file, every time it tries to find a unique merge target for any merge candidate, a header file, it says, I can't actually find one. As a result, those files pop up in the unmerged files viewer. Let's edit this rule and make it a teeny bit more specific, still a very bad rule, and say, actually, instead of saying any file, I'm only interested in performing the merge if the header file is included by the body file. That sounds like a good constraint to be defining in a merge rule. So let's do that. Oh dear, I was worried that was going to happen. I seem to have a slightly buggy version here for the demo, where rules aren't always applied immediately. So if I switch it off and on again, then it gets applied. I'm sure that'll be fixed for the release version. So what we see now is we successfully merged 3,247 files, but approximately just more than half of the files are still unmerged. So in this case, what the rule says is wherever you find a header, merge it to the body if it's included by the body. And because it's always looking for a unique merge target, otherwise it won't perform the merge, there's quite a large number haven't succeeded. And that's absolutely right, because this rule is still extremely vague. If a header file is only included by one body file anywhere in the codebase, this rule says merge it to that body file. And that will be right in some cases. I think on most code bases you'd actually have a lower success rate than here. But it's certainly likely to be wrong in some cases. And if I scroll to the bottom of this viewer now, I can see that, for example, the header file signal.h, which is off somewhere in the headers area, is being merged into a uassert.cpp off in an area of the codebase. Now, given that that's the only file that's actually using signal.h, maybe it's not horribly wrong, but it certainly feels dubious. And the issue really is that our patterns at the moment say any header file, any body file. There's no attempt to say there should be some similarity in terms of location or in terms of name. And we can do that by tweaking the syntax of the rule. So let's do that now. Let's edit this pattern. So I'll loop back at the end and explain, give a bit more detail about the exact semantics of wildcards in patterns in Structure101, a teeny bit non-standard. But the key in this context is that wherever I use an asterisk in a source rule and a target rule, it means any, well, it means whatever it means, we'll come back to that. And the two are independent, so there's no relationship between whatever matches in the source and whatever matches in the target. If I want there to be a relationship, I use this rather clunky syntax of some variable name in squiggly brackets, and then I duplicate the variable names in both. So wherever I had the first asterisk before, I've changed to squiggly brackets with an A in it, and the second one I've changed to squiggly brackets with a B in it. So this now means that for any file called something.h in some directory, if there's a corresponding file called the same something.cpp in the same directory, headers and bodies co-located, then perform the merge. And if I run this now, I'll get a much improved result. In fact, I didn't find that many more merge candidates, but this rule is now the definition is much tighter. So it's much less likely that I'm going to accidentally pick up merges from, for instance, accidental naming collisions aren't going to happen where I happen to know that the header and body files are co-located. If my headers and bodies weren't co-located, but for instance they're in parallel directory structures, then I could use that as part of the expression. So wherever I've used A here, I might use H files squiggly brackets A, C files squiggly brackets A, or whatever. If I have a naming convention that allows me to track that down, I'd be able to capture that in the pattern I defined. So this has told us that we've now got 3,753 merged files. That looks good. We've still got a lot of exceptions here, 2,969, things that aren't being merged. And there's of those exceptions, it's absolutely right and proper that some shouldn't be merged at all. They have no natural merge target. For instance, system headers. Now we can just leave them in this window down here being reported as exceptions, but it feels a lot nicer and tidier if we can define rules to get them out of, define a rule to say, for instance, I don't want to merge these at all, and then they won't be reported as exceptions anymore. And I'm going to do exactly that now for this headers area, which has got 16 files in it. I know I never want to merge these. I might, by the way, define a pattern in the project properties as excludes if I don't want to see them at all. If I do want to see them, with the way I've defined my rules so far, I should probably exclude these from the merge process. So let's define that rule now. I'm going to select the headers area down here, So define a new rule. The suggestion, it's not a bad suggestion, but we can probably improve it. So I'd like to take out as much of the directory structure as I can to keep the rule general. And it's also missing, I happen to know, a level in between. So this says for any directory called headers in some location further down the tree, where I have some number of directories in between, and then I have a file called .h, do not merge it. I'm going to do that now. And the effect I'll see is that those 16 exceptions have now gone away, and I've still got 2,953 files which aren't being merged, but which I maybe should be or should be dealt with. But I got rid of those 16 at least. So really the approach now is to look through some of these remaining exception cases, seeing if we can spot either very specific exceptions that we want to handle, or whether there are more general cases. There's one down here which is kind of interesting. If I pick this particular header file, I mentioned before the merge candidates is intended really to help me track down and understand problem cases. So at the moment it's saying, okay, for the selected file, this km annotation pointer.h, show me all files which include that file and which are body files. So let's switch a couple of those off and just say, I wonder if there's anything out there with the same name. And there is in fact a header file with the same name. If I say pick the filter, show me only show me files which way around is it? Which the current file includes. And then in fact we have a bit of a pattern here in the code base as a form of forward inclusion, where I might have a file with a particular name, a header file, which typically in a subdirectory called include, which includes a header file with the same name in some other directory. See what that looks like in practice if we try and define that. So I'm going to use this little viewer down here to give me a very explicit rule, which says merge this file into this one. So this isn't capturing a general case at all. But now I'm going to go and edit him and remember to pull it down. So we said if we have something in include and we have squiggly brackets a.h, and then that has in some directory the same name .h, and it includes that file. Let's have a look at the effect. This takes a little while to go off and do its stuff. And I think I've got my update logic here as to when the viewer refreshes. It's confused. I'm going to switch the other ones off anyway, because I just want to get an idea of what's the particular effect of this rule. If I switch it off completely, nothing happens. Now if I switch it back on, am I going to catch any? Yeah, so it did in fact catch 2,763. I'm just fighting with the automatic refresh here in the UI a bit. I wonder at this stage, is the order significant? I don't really know if it is or not. I think you'd have to know the code base. So if I activate all three of my rules now, I've ended up with a very small number of problem cases. And we can imagine maybe looking through here, looking for particular issues. Is there anything we can do with this guy? How many guys with the same name? And go off and define the rules. The idea, if we have more exceptions and maybe very special cases, we can record those. The aspiration, if you like, is that we'll end up with no exceptions. And going forward, we try to keep it at no exceptions. I won't subject you to the detail on that right now. Okay. Apart from a bit of work around the pattern syntax, we're nearly done. A couple of other things I should quickly mention just to wrap up the key aspects here. The merge rules will dramatically affect the way the model is displayed in Structure101 in all the other perspectives. And whenever I want to apply changes to those merge rules, I have to reload the entire model. That's a little bit time consuming. So the merge perspective actually simulates the changes just locally in this perspective so that it can be reasonably responsive. And that means that if I switch over to another perspective now, all the changes I've made, I'll switch that over to graph, don't actually have any effect until I hit refresh. Now, in fact, I left this particular project in a slightly undefined state before, as a result of which I'm seeing some blue arrows already. Normally I shouldn't see any. Anyway, when I do this, I hit refresh, and it does a complete reload. In this case, includes only still, and performs all the merging. Whenever files are getting merged together, I see these blue arrows popping up. Note that the project is dirty. If I save the project, my little asterisk there has gone away. Next time I load it, all those merge rules will be applied straight away. Another thing which can be useful, let's just go down into some file which got merged. I see from the blue arrow. If I use the source viewer, in this particular case, I don't actually have the source set up on this machine. I don't have the source paths available, but even under those circumstances, this little source viewer can be rather handy. As I navigate around different files, I can see in effect, okay, this is really a module. What's being displayed as the contents of this file is actually the result of multiple merges. Now, theoretically, one file can have multiple files merged into it, and then I'd be able to browse the individual source files by selecting them here. That's kind of another useful way of understanding the effect of the merge rules in any particular context. Okay, we'll finish up. We'll cover the syntax of the patterns. I'm going to do this in the architecture perspective. It's a bit easier to see the result. In general, we use the same syntax for patterns and architecture diagrams, for excludes, for transformations, and for merge rules. I'm going to let it create a diagram for me. It's probably the easiest way. So what I see here is that a cell in an architecture diagram has a pattern, and through that pattern, a number of items in the codebase get associated. Most of this will be clear from before. I could change this particular pattern to star btest star, and that now means it's in fact the same as we had before. Some number of directories above btest, and then any number of items below. It's worth understanding the significance of a forward slash in these patterns, and that we treat these as somewhat hierarchical, as a tokenized string, where the forward slash represents the delimiter. In Java, we'd use a dot. Within that context, we interpret the wildcards star and question mark slightly differently. Star means any number of tokens or characters, depending on context, and question mark means exactly one token or character, depending on context. So if I change this to a question mark, what we're now picking up is any files directly located in btest. So anything which is there but not in some subdirectory. If I said question mark, we would now be picking up any files which are located two directories down, or sorry, one directory down from btest, and then the file level. We could also say in here a star. Now, because this is within the delimiters to forward slash, this will now be interpreted as a bunch of characters, and so it will still match the btest pattern. That's kind of the important details to be aware of, I think, with the patterns, is the role of the star and the question mark. There is some more documentation on this in the help, and in general, it's always a good idea to play around. Let's just do one more little fun one. We could do a show me any CPP files at that location. If I said show me any H files at that location, I'm not going to find any. Okay, that's just a quick overview of the syntax there. And so thanks a lot for watching, and till the next time.